Chapter 8, Laplace Transform. In these chapters, we're going to cover three main subtopics, which include introductions to Laplace Transform, inverse Laplace Transform, and solving second-order differential equations by using Laplace Transform. Without further ado, let us get started. The Laplace transform of a function ft is defined by this integral, which is integrations of e power negative st ft dt. The integrations has the boundary conditions from 0 to infinity, and the s here is a parameter which assumed to be a real number. This is the common notations for the Laplace transform. It can also be noted in this manner. For consistency, throughout the chapters, we will use this as the notations for the Laplace transform. Linearity property of the Laplace transform. As we know that Laplace transform can be presented in this integral, in the case that we are doing Laplace transforms for a function which is multiplied with a constant k, substituting into the equations, you will obtain this. Since the k here is a constant, it can be brought out of the integral, which gives you this. In this case, we can conclude that Laplace transform of kft can be rewritten in the form of k multiplied Laplace transform of ft. In the case that we need to do Laplace transform of a function here, if written in the mode of the integrations, it will be something like this. These functions can further be expanded into this manner, and this leads to a conclusion that Laplace transform of these functions can actually be expanded into this manner, where the constant can be brought out and leaving inside it will be the functions for the Laplace transform.